Hello, everyone. Welcome to our exciting presentation. Today, we're diving into the fascinating world of chemistry. The title of our session is Knowledge of Everything. Before we start, please don't forget to comment, like, share, and subscribe to our channel. In this presentation, we'll explore some fundamental concepts of chemistry, uncover interesting facts, and hopefully inspire your curiosity. So let's get started and enjoy the journey together. The word chemistry actually comes from the Greek word chemia, which means to cast together. So, at its core, chemistry is about combining things and understanding how they interact. According to Roald Hoffmann, chemistry is the science of molecules and their transformation. That means we're really looking at the tiny building blocks of matter, molecules, and how they change, combine, or break apart. Chemistry deals with the composition, structure, and properties of matter. Think of it as the science of atoms and molecules because everything around us is made up of them. It's the study of matter and how it changes, whether it's a simple reaction or a complex process. Now, why is chemistry called the central science? Because it provides the fundamental knowledge needed for other fields like biology, physics, geology, ecology, and many more. Understanding chemistry helps us make sense of how everything in the natural world works and interacts. In essence, chemistry is all about understanding matter and its changes. It's the foundation that connects so many other scientific disciplines and helps us understand the world at its most basic level. Science can be thought of as a continuous effort to organize knowledge in a way that helps us describe and understand the natural world around us. To make this easier, science is divided into different disciplines such as chemistry, physics, and geology. Each of these fields focuses on specific aspects of nature, but they all work together to expand our overall understanding. Although chemistry is one of the oldest sciences, its modern foundation was established in the 19th century. During that time, significant intellectual and technological advances allowed scientists to break down substances into smaller and smaller components. This breakthrough helped explain many physical and chemical properties of materials. Chemistry, in particular, plays a crucial role across numerous areas of science and technology. For example, it's essential in health and medicine, helping us develop new treatments and improve patient care. It's vital for energy production and environmental protection, contributing to cleaner technologies and sustainable practices. Chemistry also impacts food and agriculture, ensuring better crop yields and food safety. Overall, the importance of chemistry is vast because it underpins many innovations that affect our daily lives. It helps us solve complex problems and drives technological progress, connecting deeply with the broader goal of understanding and improving the world around us. Energy is a byproduct of many chemical processes, and as the demand for energy continues to grow, we see this happening not only in technologically advanced countries like the United States, but also in developing nations such as India. Chemists are actively working to discover new energy sources to meet this rising demand. Currently, our main sources are fossil fuels, coal, petroleum, and natural gas. However, the reserves of these fuels are estimated to last only another 50 to 100 years at our current rate of consumption, which makes finding alternative sources absolutely urgent. Now, it's important to understand that energy production and how we use energy are closely linked to the health of our environment. Burning fossil fuels releases carbon dioxide, a greenhouse gas that contributes to the warming of Earth's atmosphere. It also releases sulfur dioxide and nitrogen oxides, which are responsible for acid rain and smog. These are significant environmental concerns that we need to address. One promising solution is harnessing solar energy, which has no harmful environmental effects. Additionally, by adopting fuel-efficient vehicles and utilizing more effective catalytic converters, we can greatly reduce auto emissions and improve air quality, especially in busy urban areas. Looking ahead, electric cars powered by durable, long-lasting batteries are expected to become more common in the next century. Their wider adoption will play a key role in minimizing air pollution, making our environment cleaner and healthier. So, in summary, exploring alternative energy sources is not just about meeting our energy needs. It's also about protecting our planet for future generations. You are already familiar with the term matter from your earlier classes. You know that matter exists in three main states: solid, liquid, and gas. But today, I want to introduce you to two other fascinating states of matter that also exist in our universe. The first is plasma, which is actually the most abundant state of matter in the universe, found in stars, including our sun. Plasma is like a super hot, ionized gas, where particles are energized enough to break apart into charged ions and electrons. The second is Bose-Einstein condensation, a very unique state that occurs at extremely low temperatures, close to absolute zero. In this state, particles start to occupy the same space and quantum state, acting as a single quantum entity. Understanding these states helps us see the diversity and complexity of matter beyond just solids, liquids, and gases. It also connects to the overall theme of exploring the different forms matter can take in our universe. Methane is the simplest example of alkanes, which are a fascinating group of organic compounds. We often call them saturated or paraffin hydrocarbons because of their structure. They have a very straightforward bond between the carbon atoms, and each carbon atom's remaining valencies are filled with hydrogen atoms. This simplicity makes methane a great starting point for understanding more complex hydrocarbons. One of the most important reactions that alkanes undergo is combustion. When they burn, they produce water vapor and carbon dioxide gas. This process releases a significant amount of chemical energy, which can then be transformed into electrical or thermal energy. Now, focusing on methane's reaction with oxygen, this is the classic combustion process. When methane reacts with oxygen, it undergoes a highly exothermic reaction, releasing energy that powers many applications in our daily lives. Understanding this reaction is key to grasping how fossil fuels are used and how energy is produced from hydrocarbons. Now, let's take a closer look at the reaction of methane with oxygen. As you can see on the slide, the molecular structure of methane is represented by the central carbon atom bonded to 4 hydrogen atoms. When methane reacts with oxygen, it undergoes a combustion reaction. The chemical equation shows that methane combines with 2 molecules of oxygen to produce carbon dioxide and water. This process is a classic example of a combustion reaction, which is highly exothermic, meaning it releases a lot of energy. The key points here are the reactants, methane and oxygen, and the products, carbon dioxide and water. This reaction is very important because it's a primary source of energy in many contexts, like heating and electricity generation. Understanding this reaction helps us see how hydrocarbons like methane are used as fuels, and it also highlights the importance of controlling combustion to reduce pollutants. So, in essence, this slide illustrates the fundamental chemistry behind how methane burns in the presence of oxygen, releasing energy that powers many of our daily activities. Let's take a closer look at the Grignard reactant reactions, specifically with carbonyl groups. These reactions are fundamental in organic synthesis because they allow us to form new carbon-carbon bonds efficiently. When a Grignard reagent interacts with a carbonyl compound, such as an aldehyde or a ketone, it acts as a nucleophile, attacking the electrophilic carbon of the carbonyl group. This results in the formation of an alkoxide intermediate. What's particularly important here is that this reaction can be used to synthesize alcohols, primary, secondary, or tertiary, depending on the type of carbonyl compound involved. For example, reacting a Grignard reagent with an aldehyde typically yields a primary or secondary alcohol after workup, whereas with a ketone, you usually get a tertiary alcohol. Connecting this to our overall theme, these reactions highlight the versatility of Grignard reagents in building complex molecules. They serve as a cornerstone in organic synthesis, enabling us to construct a wide variety of functional groups with precision and efficiency. Let's take a closer look at this reaction. 2-RMgX reacting with CdCl2 to produce artacide and 2-MgXCl. This is a type of Grignard reaction involving non-carbon electrophiles. The key point here is that while Grignard reagents are typically known for attacking carbon-based electrophiles, they can also react with other types of electrophiles, like metal halides. In this case, the magnesium halide compound, RMGX, reacts with cadmium chloride, CdCl2. The magnesium transfers its organic group, R, to the cadmium, forming artacide. Meanwhile, magnesium binds with chloride ions to produce MgXCl. This example highlights the versatility of Grignard reagents. They're not limited to carbon electrophiles. Instead, they can participate in reactions with metals or other non-carbon species, expanding their usefulness in synthesis. Connecting this to the overall theme, understanding these reactions broadens our perspective on how Grignard reagents can be employed in various chemical transformations, especially when targeting different electrophilic centers beyond just carbon. Thank you so much for being with us through this entire presentation. As we reach the final slide, I want to leave you with a powerful idea: knowledge of everything. This phrase really encapsulates the ultimate goal of continuous learning and curiosity. It's about expanding our understanding to a point where we can connect ideas, solve problems, and innovate in ways we never thought possible. And remember, your engagement helps us grow too. Please comment your thoughts, like if you found this valuable, share it with others who might benefit, and subscribe to our channel for more content like this. Thank you once again for watching and being part of this journey. Keep seeking knowledge, keep pushing boundaries, and stay curious.